Hello everybody and welcome back to Space Engine. I am actually chilling around a planet around Proxima Centauri because I don't know why not. And if I'm correct, that is our sun right there. Yep, that's our sun. I was actually I was playing around with just locales in Alpha Centauri. Yeah, there's Alpha Centauri A, Alpha Centauri B. No, wait a minute, that's Proxima, that's one of the planets. Where the hell's the Alpha? I'm correct, they were bright stars off the edge somewhere. Is that it? Yeah, there we go. There's Rigel Kentaurus. Anyways, that's not important. We have places to go and things to do. Lots of stuff to do, actually. People have been telling me to go to a lot of places. Let's check. I have some other suggestions here. Going to a quasar. That sounds like fun. Let's go there. Copy and see if it gets to work. Nope, wrong one. I always forget. Wait, it wasn't it F3? It is F3, alright. Come on. 1 second. I don't know, it's been a little while. I'm doing this really badly. There we go. Let's go. Yeah, I was hanging on Alpha Centauri because I was just thinking about stuff the other day. So this is a marine terrestrial organic, and it's chilling out by a quasar. So what, like an active galaxy? That's a nice planet. But I'm kind of curious. Where are we? There's the star. Well, it's maybe. Let's check. I think it's a quasar, yeah, so it's an active galaxy. Weird. Yeah, you'd think that there would be too much radiation for that. That's actually interesting. Let's go back to that planet so I can actually check some stuff. Ah, come on. Why won't it? No, wrong one. Come on. Alright, it's not letting me pop up the menu. Why won't the menu pop up? Alright then, I guess we're not doing that. How will the menu pop up? I'm really confused by this. F3. It's not working. 1 second. Right then, let's see if it'll work. There we go. Anyways, let's go back to our planet here and check some things out about it. Boom. Info. It is a planet. I should hope so. Atmosphere. Mostly nitrogen, bit of oxygen, some carbon dioxide, some water vapor, sulfur dioxide, helium, argon, and neon. That's actually not bad. It's actually very similar to our atmosphere in terms of oxygen to nitrogen. Huh. But what density are we looking at here? Parent size, magnitude, what is the pressure? 2.25 atmospheres. So it's denser. It's like twice as dense as ours. Interesting. I guess it's kind of like, what was it, Pandora from Avatar? Had a dense atmosphere. It was also poisonous to humans. Actually, speaking of that, I always think about Sid Meier's Alpha Centauri, you know, the game from the 90s. I love that game. I actually still have it somewhere. And how it's like, the planet in that game was very similar to Pandora, only it came before Avatar. No offense, James Cameron. Anyways, what else? Planet from the Pleiades, has life, a habitable moon in the Milky Way. I like habitable moons, let's go there. No offense to the Pleiades planet, but I don't really, right then. Control V. Ah, it's a question mark. God damn it. Why would there? There's no question mark. I don't know why it does that. It's like there's no question mark in the actual copy paste, but it puts one in, and I don't get it. It's weird. Anyways, yeah, 'cause, in Alpha Centauri, like the games, in Mars Alpha Centauri, the planet, which is just referred to as planet. You know, its actual name is Chiron, Chiorn, something like that. Oh, what's the lovely planet? This is a moon. Oh, that's a really bright star. What is it? Where is its host planet? Anyways, and it's a planet, and it's orbiting Alpha Centauri A. So it isn't a moon like Pandora, mind you, but it's still. Oh, there's its host. That's a wise way. So, but like, it's a planet in the Alpha Centauri system. The atmosphere is poisonous to humans, but it's great for Earth life because it has a lot of like carbon dioxide in the atmosphere, just like Pandora. And also, one of the most similar features about it is the planet in Alpha Centauri. All of the flora and fauna are like interconnected in this collective brain that like develops sentience throughout the game. Just like in Avatar, when all the animal and plant life is connected in this web of a sapient or a sentient kind of group mind. I don't know. I don't know what it is with Alpha Centauri and having collective mind planets, but that seems to happen. A lot of oxygen here. Only difference being that there aren't any mind worms on Pandora, and there's like nothing but mind worms on Chiron. Which always makes a joke, you know. It's like, oh, you'd rather go hang out with mind worms than like, it's like in Civilization in the games. Up until 6, anyways, all the ones up to 5, when you win the science victory, you basically send a colony ship to Alpha Centauri. But yeah, so you can be like, you know, oh, I'd rather just go hang out with mind worms in Alpha Centauri than deal with the geopolitics of the game. It's always funny. I find it amusing, anyways. I love that game. I should actually pull it out and play it, because like, it might work. I know it. Well, this is a brown dwarf. Ooh, fantastic. I know it worked on my computer when it had Windows 8, and it might work on Windows 10. It's kind of hit or miss with anything above Vista, but you know, give it a shot, kind of thing. Oh, look at you. Very generic looking. Very nice looking though. I like it. But it's a really fun game. I should play it. Actually, speaking of older games, I also got Roller Coaster Tycoon 2 because it was on sale, and I was like, hell yeah, I'm playing that. Oh no, I want the planetary info. And it's actually a lot of fun. Like, I love it. Info. There we go. Nitrogen. Oh. There's no free oxygen on this planet. Oh, well, it's exotic. Okay, I guess that makes sense. Isn't that methane? CH4? Pretty sure that's methane. Or is that propane? Oh, this is happening again. Oh, it is methane. Right, I'm trying to remember the little diagrams and how they look. I guess it's a frozen Titan. So this is kind of like Titan, like our Titan around Saturn. A lot of methane, nitrogen in the atmosphere, some carbon monoxide, argon, neon, krypton, C2H4, isn't that? That's one of the, C2H4. That's ethylene. Yeah, okay. It's one of the ethane groups. You know, I should just, like, keep all of these, like, on a piece of paper on my desk so that, like, I have a quick reference guide, but that's what the internet's for, I suppose. Yes. Alright, where to next? RS, ooh, that's a lot of them. Well, I'll do the first one. Anyways. F2. Nope. There we go. No, I love Alpha Centauri. It's such a great game. And a great star system. I want to go to Alpha Centauri. Oh, object not found. Did I do something wrong? Oh, yeah, I forgot to put RS at the front. Oops. I've actually been kind of thinking about unmanned and manned missions to Alpha Centauri a lot recently. More or less for fun, but also because it isn't impossible. It just requires a lot of money and time. Boop. Oh, that's delightful. Well, it depends on what route you go. Whoa, 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 whoa. What is this? we're gonna check that out first, because that looks interesting. It's way the hell over here. It gets like almost no thermal energy. It's dark. That's kind of cool. What's this? Ice giant. It's a white dwarf and a brown dwarf. This one has a planet with life around it. Oh, it's the planet itself. So it must be floaters. But no, it's like it depends on what route you go. Because like, you know, if you do like the antimatter engine idea, well, it requires a bit more R&D. But you know, you could theoretically use that to get upwards of speeds of like 50 to 70% the speed of light, if done right, mind you. And then it would just take, well, 6 years Earth time to get to Alpha Centauri, about 5 or 4 years ship time because of time dilation, and then you bum around there for like a year or two doing science, and then come on back. Actually, I worked it out where it's like using the 70% the speed of light margin plus a 3-year stay in Alpha Centauri, you could do an entire mission round trip to there and back in 15 years. But again, it requires an engine that can get you going that fast, which is questionable. The other idea I was looking at is like black-body photon drives. It's actually quite interesting. You use black-body radiation to basically generate thrust, whereas basically it's like when you have something that's actually, I'll keep talking while I do this. You have something that's like in equilibrium with its environment. It'll dump out as much energy as it brings in, and that's what these thrusters work on. Because like you have a black body material, yes, and basically what you do is you just dump in a lot of energy into it, and then it, you know, will radiate a lot of energy in the form of photons, and the photon pressure generates thrust. So you could theoretically have a ship that could travel close to the speed of light and expend no fuel. Only problem is it produces very, very little thrust. It's like, I think it was like using current technology with optimum, like you operating optimally, it would take a year of thrusting just to leave Earth orbit, and then like 8 years to leave the solar system in terms of like to get the speed to break out of the sun's gravity. So a lot of work is needed, but theoretically, if you could get more energy into it, you could possibly start to get higher ISPs out of it, like specific impulse, which would be great. Because if you could get a photon drive with reasonable ISP, then it would actually be reasonable. But right now, it's not reasonable. I kind of want to work on it, but I don't have a vacuum chamber. And the idea I have involves using graphene or tungsten, and I don't have either of those, so sucks to be me, I suppose. There's a lot of carbon dioxide in this atmosphere. Nitrogen, free oxygen, always good. Water, sulfur dioxide, neon argon, and carbon monoxide. Lovely. A lot of it's always sulfur dioxide, but again, the 4 main ones here. Always look for those ones. These little atolls. Are those made like volcanically, or are those well, it depends. On Earth, atolls are made because what you get like volcanoes in the middle of the ocean, basically, and then you get coral reefs that build up on the edges of them, because, well, that's just how coral rolls. And then over time, the volcano itself erodes back into the ocean, and then the coral reef is left behind, which usually collects sand and produces sand, because as a lot of sand is rocks and coral skeletons basically broken up into grains. So you get these little sandbars that are then the remnants of a volcano that once were. I'm pretty sure, anyways. I know that's how a lot of atolls form. I'm sure atolls can form in other ways, but judging by this here volcano in close proximity to those atolls, I'm going to say my theory is, well, my hypothesis is, well, not that bad. Actually, it's kind of cool because the sand will be a different color depending on the local geology or the local, basically like what's in the ocean. So like if you're on a volcanic island, say, sometimes you get sand that's just black. It's just black sand because it's pulverized lava rock. Whereas the white sandy beaches, like the really white beaches, come from coral that's been broken up and then it bleaches and you get coral, or you get this white beach sand. But you can also get multicolored sand sometimes from, again, coral that doesn't bleach. Or actually, I'm not quite sure where the colored sand comes from. I know it involves coral, but I always thought that it bleached into the white beach sand that we get. So yeah, if you ever look at beach sand, like especially ocean beach sand under the microscope, you see a lot of small shelled creatures and like shells, bits of shells, and you can tell that it's made from pulverized skeletons, basically. But coral, so it's not like, you know, spooky and scary. This is a nice place. Well, actually, that's not to be seen yet. That's a lot of carbon dioxide. I take back that statement. This is not a nice place. It's also a very thin atmosphere. So it's kind of like a less crappier version of Mars. You know, because this place actually has enough atmosphere to maintain liquid water on its surface, unlike Mars, which does not. Which is sad, because I like Mars. I mean, it's not my favorite place, but I do like Mars. Who doesn't like Mars? It's a fun place. It's the coolest place on Earth. Oh, God. Somebody's telling me to go to NGC 1101, then IC 1101. Is that, okay. Well, might as well. So let's just go there. F3, F4. Go away. Wait. There we go. Get my tab out. Begin with the question mark. I hate that question mark. Well, I'll do. There we go. The dumb question mark thing really annoys me. And that's broken now. Oh, no, we're good. Oh, look at you. Aren't you pretty? Now, I'm actually going to check something quickly, because I'm curious. Are these the same things? No, they're not. Huh. I learned something today. We got elliptical and well, yeah, a spiral and an elliptical. Well, we can chill out here. Actually, this guy wanted me to do something here. This is the core of IC1101. So, alright. We're gonna chill out near the core of this for the rest of this video. Come on, stars. Oh. Well. It's kind of interesting. I've driven through fog this bad before. Well, let's just find some stuff chilling out here in this here planet, or this here galaxy. Oh, there we go. A yellow dwarf with life. Oh, let's not do that ever again. Ooh. This looks like it'll be an interesting planet. Go away. Okay, it's nothing special, but it's kind of nice. It actually reminds me of a hypothetical planet that I thought of once. Huh. It was like an oceana with a thin ring system around it. And with marine life, that actually also goes along with it. Let's check the information here. Its atmosphere is different than what I imagined, though. Holy expletive, Batman, look at that. That's a pretty thick atmosphere. Well, it's not going to be a lot. It does have aurora? It does have aurora. So it has a magnetic field and an incredibly dense atmosphere. So I'm going to go off on a limb here. Actually, how much oxygen was here? Or how much hydrogen is in this atmosphere? Not a lot, but there is water vapor. A fair bit of it, too. So I'm going to go out on a limb here and say that life that lives in the ocean of this planet probably does not get a whole lot of radiation from its, like, just reaching it. That's one thing about dense atmospheres that's good is it blocks out more radiation. Especially if it has a lot of hydrogen in it, it's like a lot of water vapor. Like really dense, watery atmospheres are better for that. Oh wow, we're going really fast. Oh, how lovely. Okay, I'm going too fast now. That's actually why, you know, bottom of the ocean is a good place to hang out if you don't like radiation. Because, you know, not a lot of it reaches you down there. Oh, you can just barely see the rings. Actually, it's always that's why, although Europa orbits around Jupiter, and it's, you know, high radiation zone, life that lives there probably gets like less radiation exposure than we do because it's underneath really thick ice, and the ice would shield like almost all of the charged particles. So, yeah, that's pretty cool. But that's 21 minutes, so I'm gonna end it there. I didn't miss anything, did I? No, I didn't. Well, I think somebody turn off the blur effects. No, I like the blur effects. I like being blinded by the stars. But, yeah, thank you all for watching. I hope you enjoyed. There wasn't really a singular topic of this episode, but whatever. If you have ideas, leave them in the comments below. Locations, all that jazz. And thank you all for watching. Space.